Okay, yeah, this is going to be a little bit different. This is like more big picture-y and less here are like things that we are implementing next week or two. But I thought it would be good to think a little bit about like, well, what's the kind of bigger situation with AI and how do we fit in and how are things developing? It's going to be pretty informal. I hope it can be pretty interactive. A lot of the slides I've only kind of written yesterday at 8 very quickly, looked at only once, so especially towards the end, it will get increasingly unhinged.
Wait, do you have 2 cameras?
I do, yeah.
Wow.
This is for the audience and this is for me.
Wow.
I know.
Are you vlogging this?
I haven't decided yet what to do with it,
we're
but
a $10 trillion company.
Trying to get big on YouTube.
This will be in the documentary.
Watch is probably just recording his chest.
well, that's why I have multiple cameras. Actually, I have 3 cameras. This one is also recording.
Oh, wow.
Okay, but let's focus on the content. Okay, so the first question I want to raise is something like, we all think AI is not really human level yet. So where do we see this, or like what's lacking? Actually, I would like audience input on this one. What are the specific behaviors that we see that make us think this? And then once we've discussed that, maybe we can think about what are the underlying abilities that are lacking. James.
Thank you. You can refer back to a conversation you had yesterday.
It doesn't have memory of that kind?
I was going to say, it doesn't have context. It can't see and hear everything you can see and hear, and so it inevitably gives you the wrong answer because it just can't get enough context for what you're trying to do.
Like it doesn't have the perceptual mechanisms, or it doesn't have the knowledge, or both?
In the broader sense of perceptual mechanisms, maybe in the more narrow sense of a piece of software, it can't see like all the apps on your computer or what other documents you have open and what time of day it is and that kind of thing.
Metacognition level seems kind of bad.
What does that mean?
Just ability to make plans that make sense and don't go off the rails over a bit of time, or assess like why a set of actions might or might not make sense. Things that are like more implicit in an artifact than explicit, like you produce a thing that makes a lot of sense, but then the level of explaining why does this thing make sense or why might it not make sense is not at the same level as the ability to sort of produce the thing, it seems like.
It's a little bit related to context also,
Yeah.
like it doesn't know what makes sense in a context.
I think like agency, like if you wanted to use GPT to create an agent, a big struggle is that like none of the training data is like good data for encoding this kind of like understanding tasks and how consequences follow from planning and etc.
Yeah, it's really similar to
it lacks the training data to effectively pretend to be an agent.
Yeah, these are. Anyone else want to say anything?
It often betrays patterns in the pre-training data, which are very unusual things.
Like what are you thinking of?
Like the 2 tons of bricks versus 1 ton of bricks.
Yeah.
Yeah, I think just more on the sort of metacognition point that Panda said it better. I think there's just like the training data is like really missing you might have a document, but you don't have the process that went into writing the document. People didn't like write out their thoughts and what they decided not to write, why they decided to write what they wrote. But then that's much sparser and not really linked up as much in the same thing.
It might be helpful to distinguish between actual humans and idealized humans. Just lots of humans make that mistake.
Yeah. To be clear, I'm specifically interested in like why is it not at the level of the best humans? I think it actually is at the level of like many humans at many tasks where you don't really pay attention. Okay, those are all really good thoughts. So one specific thing I wanted to highlight is so in terms of where we are seeing this is that like AI is actually kind of great at tests. So like is like I don't know 90+ percentile on LSAT and like various other kinds of tests. But so kind of surprisingly, 88th percentile on LSAT, 99th percentile on GRE verbal, 89th percentile on SAT math, which is like quite good, I think. but there are basically no novel ideas that have been generated by these systems, like almost like to a surprising extent, because like millions of people have used it. I think thousands of people have tried it on like various grad level exams and like asked it like, hey, can you give me research ideas and things like that. And there's basically no field where it has like generated any interesting ideas. And so if a human knew as much as say GPT-4 knows, I think they would have been like, oh yeah, there are like these connections, or like this makes me think of that, or like if you then prompt this human to help you on a thing, they would probably often generate like stuff that is surprising to you. But I think GPT-4 just isn't like that. So it's really not good at combining knowledge in a way that humans would.
Rarely surprising is like a good.
Yeah, it's rarely surprising. Like everything is kind of a thing where you're like, yeah, probably something like that is in the training data somewhere. And then so that's kind of the observed behavior, is no novel ideas. And then the question is like, wait, why is that happening? And I think one possible answer, I think, is it's kind of lacking the right level of generalization or abstraction. It's kind of storing knowledge still at like a relatively shallow level, where it can't abstract the patterns. Like a human would maybe be like, oh, I saw this pattern in physics and this other pattern in chemistry. They have a thing in common. I can maybe apply this to biology as well. And then that's like the sort of thing where you're like, oh, that's like maybe an interesting novel idea. But I think AI systems currently don't have that. Like all the knowledge is like at a fairly kind of detailed level of abstraction. And I think another way, these are going to be all kind of the different ways to look at the same thing, but another way to think about this is like models are still like very data inefficient. Like they learn, I mean, they're really good just because they have so much data to learn from, but they're not like, if you read a paper, I think you're going to learn a lot more if you try than an AI system. I think it's going to learn lots of specific things, but it's not going to be like, oh, I'm going to make like these kind of deeper updates to my world model, or I'm going to like learn how to approach certain kind of problems more generally. It's going to be like very, very specific. And I think like my friend of Wine actually had like a really interesting paper on that recently. So he calls this sort of learning during pre-training out of context reasoning, and I'll show the example. So the specific example is, imagine for now, just look at the left to start. You're prompting a model, and if you tell a model in the prompt, Tom Cruise's mother is Mary Lee Pfeiffer, and then you ask, who is the son of Mary Lee Pfeiffer? The model will be great at being like, it's Tom Cruise. That's like a very very easy inference. But if in the training documents you have the same statement, Tom Cruise's mother is Mary Lee Pfeiffer, just like as part of pre-training, and then in the context you ask, who is the son of Mary Lee Pfeiffer, it'll actually say, I don't know. Like it won't have made the inference that kind of from the fact that his mother is Mary, you can infer that Mary's son is Tom Cruise. So it's storing this knowledge in like a very specific way, where it can only access it if you ask for it in the right way. This is Wine calls it the reversal curse.
Question: do you think if you asked who Tom Cruise's mother is, it would get it right?
Yeah, I think so, because it is kind of, the model is kind of following the sequence, like it is being trained to be a sequence predictor, and it is. I think he actually showed this for various examples, that it does get it right in one direction, and doesn't get it right in the other direction in a way that's very surprising, because you'd be like, well, that's like a very simple inference. So I think that's like a nice illustration of this sort of shallow learning, where you're like, well, a human would probably, if they read this. I think that humans also don't always do this. I think there's like some research on human brains that are like also that knowledge is like stored in ways that work in some directions of querying, but not in all directions. But still, I think in many cases, people would learn more from this fact than models would right now.
How confident are we that this is, say, true of GPT-4 for this like level of like a thing that I could imagine is this is a thing that you slowly get with scale, where you essentially have to start doing compression, and that like certain kinds of like very easy reversals you start to get at something like GPT-4 scale, but then like that it's still pointing to a more general principle that it's shallower than like
Yeah.
the way that are like working here.
Yeah, I think this might partially be an open question. To what extent does scale solve this? I would have to look up if he tried this on GPT-4. I think he might actually have. Although I guess he has limited access to the training corpus there. But yeah, I think mostly it's unclear. Like one possibility is with scale, you will just get this for free. You will get kind of increasingly deep knowledge representations. And the other answer is there's like something more intrinsic to the training data or the model architecture that makes this relatively persistent.
I think a third possibility is something that he'll get it with scale, but very slowly, like so incredibly slowly that it's not actually at a useful pace.
Yeah. And I guess this is like a slight tangent, but there's also like a strong argument for data augmentation. Like if you take all the pre-training data, you rewrite it in various directions, then your model is going to get it because now you have augmented the training documents to say Mary's son is Tom.
Yeah, I think that's where that kind of task is only like very obliquely contained in a pre-training task, where the score is based on the document. Right?
Yeah, although I think in this case, you would think that across the whole pre-training corpus, it is a useful pattern to know that if X is the mother of Y is the son of X. I think you would actually think this will help you do some completions.
Yeah,
That's
why it's there, like kind of obliquely, but not like
Yeah.
in the pre-training task.
I would almost imagine that like you could like detect this relationship with just like vector algebra or something, embedding algebra.
All right. So my summary of this like situation that we had earlier is something like, I think what's lacking is fast updates of rich world models, which I would say is like maybe the next frontier for AI and possibly the last frontier, because then it's not clear that really anything else is required for kind of superhuman level AI. And I think I kind of obliquely made this point maybe earlier, but I think kind of shallow world models and slow learning are really two sides of the same coin, where if you're a shallow world model, then you need to remember all these individual facts, and that means you're slow to learn. So I think we should be prepared for a world where models learn kind of much faster, like much more similarly to how humans learn as they get deeper world models. So here's my picture of the situation illustrated by a small dot and a large dot, where the small dot shows the situation we're in right now with shallow world models, slow learning, little generalization. The large dot is the impressive future with deep world models, fast learning, good generalization. I think everything else I've said so far, I like mostly believe. From here on, things get more speculative, where I think a key question is like what kinds of world models, and I think it's pretty unclear whether world models are going to be implicit in the neural net weights and activations, or like some floating point number representation, or whether they're going to be more explicit as like kind of natural language or programming language or symbols, or whether they're going to be like mixed, like some language models manipulating explicit representations or various other ways of mixing things up. And you might think the bitter lesson is they'll always be implicit. There's like neural nets, they always win. Not the bitter lesson. Actually, who knows the actual bitter lesson?
How specifically it was framed?
Yeah, well, because I think the bitter lesson gets referred to a lot these days, and I think actually it doesn't always get referred to in the thing that it actually was trying to say. So curious.
Compute needs design.
Yeah.
Yeah, or like algorithms that can scale with data will win.
Like a general thing beats a specific thing.
Yeah, I think it's like something in that space. So the key quotes to me are, one thing that should be learned from the bitter lesson is the great power of general purpose methods, methods that continue to scale with increased compute, even as the available compute becomes very great. The two methods that seem to scale arbitrarily in this way are search and learning, where learning kind of refers to more like neural net-like gradient updates. We should build in only meta methods that can find and capture this arbitrary complexity. Essential to these methods is that they can find good approximations, but the search for them should be by our methods, not by us. We want AI agents that can discover like we can, not which contain what we've discovered. And one of the examples given is AlphaGo, which in fact like does like significant symbolic computation as part of that and does a lot of search.
As an example of
satisfying that, of being like, look, this beat like all of humanity's accumulated Go knowledge in like 24 hours.
Because it mostly non-search and had good meta methods.
Yeah. Mm-hmm.
Pure computation.
Yeah, pure computation. I think actually I think maybe one interesting thing is also there is actually no mention of data as far as I know. So like scaling, and I agree that scaling with compute is probably much more important than scaling with data.
I've never heard of the bitter lesson. What's the 30-second context?
I think it's basically this. It's like a short essay by Rich Sutton that says that what was like, man, I've studied like the visual system for years and built like these very specific things, and then these like compute guys come along and beat everything.
When did you write it again?
I don't know, maybe 2018 in 19.
Yeah.
Involved neural networks, like people who are trying to do like literal logic to make AI work versus that. Okay.
Yeah, kind of.
But not just literal logic. Also, I think it's more broadly kind of hard coding things. Like you're like, well, we're going to study the human visual system. We're like, let's build similar modules, and that was just not successful.
All of NLP trying to understand.
All of NLP.
Yeah, I think the reason why compute is more general than data is because you can get data from compute in a lot of ways.
Yeah.
Versus not really true in the same way.
I think it's also worth like historically, inside AI, at least like big data sets precipitated like huge developments.
Okay, so everything so far was kind of on like, well, what is the state of AI and what might happen in the near future, and then I want to address like what we see as our role in this picture, and I think our role to me is take raw reasoning capacity and channel it towards good outcomes, and specifically do so by advancing like transparent, controllable architectures. So this is kind of the I don't know. There's like the more like ML heavy version of what you're trying to do, and then there's the like what are we trying to accomplish in terms of outcomes, improve epistemics, etc. But just focusing on this aspect here, and I think to the extent that we can push explicit representations over implicit ones, I think we want to do so. I think it's like pretty unclear what is going to happen with world models and what representations will be predominant in the future. But I think if implicit representations generally are not great, like you don't know what's in them, you'll have to do a lot of interpretability to figure it out. And so the more you can push things towards transparency, the better.
Do you think that there is potentially a trade-off in terms of performance between explicit and implicit, and you could define performance on different axes? Like obviously transparency is a form of performance, but in another form, is there a trade-off there given the bitter lesson? Yeah.
I think it's very likely that there are such trade-offs, and I think partially the game will probably be in managing this trade-off well, being like here's where we can afford things being implicit, here's where we really need it to be explicit. Like for example, it could be fine to have like GPT-5 or even 6 and be like it's doing like a bunch of opaque computation, but its outputs needs to be represented in a way such that we can still manage how these AI systems interact and understand what's going on from a zoomed out perspective. And then a second response is maybe often you want to have explicit representations, but then kind of distill them into fast approximations for use at runtime. So if you know, look, here's the ideal thing, and here's how, I don't know, our system represents the world or whatever we're talking about. But in various like use cases, like deciding whether a query is about like a use case that could generate harm or something, you probably don't want to like run some complex explicit representation. You probably want to distill it into something like fast and somewhat approximate.
Yeah, I wonder if like implicit representations make sense in context where maybe you can get like robust statistical guarantees of this implicit model. So it's like, you know, you've tested this model. It was possible to test this model in many contexts, and you have some like high level of confidence statistically on what it does, and you feel like the situation where you apply it is within its distribution.
Yeah.
But then like anytime you can't do that, like there's just some action that this model will take that you can't run a million times, like some policy implementation, or it's like the way you want to use it is significantly outside of however it's been used and evaluated in the past, then you would be like much more skeptical of the implicit model or something.
Yeah.
And an understanding of when it fails, how important is that
Yeah,
to the
exactly.
user? Like in our case of search, like if we fail on that side, then that's a big issue for customers, right?
Yeah, I mean, I think I was thinking more failure at the level of like, do people die? But like,
Yeah.
yeah.
One way you can get robust statistical guarantees is by using your explicit model to test your approximation. Like you could be like, in this particular use case or this particular domain, our fast approximation always is like very close to the explicit model, and then you might also be fine with it.
What do you think about the role of interpretability to make the implicit less so?
Yeah, I think that's also great. I think you can push from both directions, and I think if ideally you don't have anything opaque, and everything is either explicit and clear by construction or by after the fact introspection through interpretability. Okay, back to world models. I think I kind of used the term earlier, but wanted to actually raise the question, like what is a world model? Well, it seems like a good audience question again. What is a world model?
I definitely think understanding mechanistic causal relationships is a big part of it.
Yeah, it feels like a big piece of predictive machinery that tells you, like, under what circumstances that meaningfully can reflect the real state of the world given a limited set of information.
Maybe it's understanding like first principles, like what is physically written into the world versus what is an interpretation.
Yeah, it kind of seems like it basically being able to take that you can't fit the entire world in your head. So how do you compress some version of the world into your head? That's what a world model is.
Yeah, as I was thinking about this, one way I found useful for thinking about world models is just their use. I think this is like very similar to what Jungwon and Panda said in the beginning, which is like it's some artifact you can use for making predictions, deductions, for considering counterfactuals, like if this hadn't happened, then what else would have happened, or interventions, if I punch James, then what happens, I predicted that. Or for doing conditioning, like if I observe certain evidence, then like what does that change about like what I believe about other facts in the world, or assigning probabilities to events. Maybe then the one other thing besides you can use the thing for this is you can efficiently use it for it. So I think if your model like takes as long to run as the world itself, I guess going back to Luke's point, then is like not helpful, because the point of the world model is you can use it to more efficiently control the world, and so you need to run it faster than real time and be able to do things that you can't do to the world itself.
No giant naive base box.
Yeah.
Or using the Earth to predict the Earth's weather.
Well, it could be that this Earth is actually being used to predict like another much more real Earth. But so as I was thinking about this, I think that was like kind of interesting to me, because it means in some sense it doesn't matter what your world model is made out of, or like your world model can be made out of very different things. Like it could be a neural net, but it could also be many other things. And then one specific thing that I want to, I don't know, I'm still kind of trying to think about myself and develop these thoughts as we go. But I think one interesting thing is to think about, well, what if we assume like you can like write down some text that describes like some aspects of the world. Maybe it includes like some programs or math or other symbolism, and then together with like a language model interpreter, that can actually be a world model. Yeah, you can try to do all these things, and you can be like, okay, given that we have this language model and this particular textual representation, we can ask counterfactuals, we can do conditioning, we can ask the model to assign probabilities to events or make predictions, and then the question is just like, well, how good is like any given world model? But it's like you can make world models out of these kinds of components. And it can be, I guess, the model could be quite large. It could, I guess, one way maybe to think about it is as something like, here's like a textbook or a systematic review or a Wikipedia page on a topic, and the model reads it, and then you ask the model, hey, given that information that you can kind of expand on demand, what do you believe would happen if we did this, or what prediction do you make about a particular outcome? Does that roughly make sense?
To clarify, you said LLM plus text because you're making the point that LLMs today on their own don't have world models, and you think just with a bit more text they could develop a world model?
Yeah, the claim is you could just use the language model out of the box, but then it probably wouldn't. I think world model is like usually maybe situation model is better. Like usually you want to model some specific thing, like you want to model how does a particular disease work or something like that, and you're going to have some distribution of questions that you care about. Probably like questions roughly of this shape, like not arbitrary questions. You probably care most about questions like what molecules affect this, if I observed that someone had this disease but also this other thing, what would I believe about how severe it is? So there's like some distribution of questions, and my claim is, yeah, if you just take a language model out of the box, it's probably like not very good at this. And then I think there's an open research question, which is how good, like, because language models are like pretty good at in context reasoning in many ways. Then the question is like, how good could you get this like language model plus, I'm not sure what to call it, like, I don't know, world model description. How good could this combination be?
Can you expand on that third bullet?
It's just a more wordy way of saying what I already said, which is you can ask like the types of questions that I have here of the language model. You can be like, hey, language model, if I gave this drug to the patient, what would I observe? And then the quality of the answer will both depend on the capacity of the underlying language model, but it will also depend a lot on like how you've structured the information given to the model.
But if this is true, then do you just assume that the next generation of language models will, being trained on this, have world models? Or are you trying to make the point that there's something weird happening in the pre-training process and you kind of need an external source of text for the model to be able to have a world model, for a language model to have a world model?
I think it could be either. I don't think I'm trying to make a claim either way. I do think maybe I have this somewhere later, but I do have a point that like if you in fact had this kind of world model made out of these pieces, then you could use it to generate data, and you could use it to like retrain your model, and so you could probably distill a lot of this into the model itself.
So is the claim like something like, given that previous functional definition of the world model, this could in principle?
Yeah, that could satisfy it, and the question is just how good can it be? There's like probably some bound, like there's probably some bound where like even if you wrote like the best possible text and gave it the best possible like tools for, I guess it doesn't just need to be text, maybe can call it Python and whatnot. There would probably still be some limit to how good it could be.
Do you think like, so I guess one thing the functional definition didn't really mention is like any kind of dynamism criticism or ability to update?
Yeah, ability to update. So that is the next slide.
Okay.
There, I was actually part of how I was thinking about this. I was thinking back to this old paper that Noah and like Erwin, another student, wrote at the time, and it had this kind of neat idea that this was in the setting of pro-stick programs, but I think it applies similarly here, which is when you update, basically what happens is you can just say, okay, I'm gonna add like a new observation to my model, and this paper tried to split up updating into adding the data point and then everything else that happens afterwards. And I don't know how easy it is to like fully explain this here, but because models were represented as programs here, you could just say the kind of generative program. You basically add a statement that's just like like the initial program is something like uniformly draw from all observations, and then you refactor the program to introduce like abstraction and kind of more generality to make it more concise. But it's like, I guess the high level takeaway is something like, usually updating is thought of as like this expensive operation because you have to like make changes all throughout your model, and you can split up the expensive part from the like kind of ingesting data part and just be like, well, we ingest data and then we refactor our model over time to better explain that data.
So is it something like in the beginning you flip a coin and you just assume it's a 50-50 coin, and then you get like 5 heads, and then based on seeing the 5 heads, there's some efficient way of saying, okay, I no longer think this is a 50-50.
Yeah, you're like, I should assume this is like a weighted coin or something. Yeah. So to go into the refactoring like operation a bit, it's something like you have your textual or symbolic or whatever representation. You have like some distribution on questions that you care about, and then you want to kind of iterate on, and this is like a thing that the language model would also do, is kind of make changes to the model to make the sort of answers that you've already observed more likely, so that you can ideally, so I guess there's like two loss functions here. One is how likely is the data that you observe under the model, and the other loss function is how complex is the model. And the initial model, like when you just like randomly add data points to it, like increasingly it gets more complex because like, well, like every observation is kind of this thing that adds, I don't know, some constant to your model. And if you can compress those observations into something more concise, like my coin always returns heads, for example, it would be very concise, then that's an improvement. So you do this, you just like iterative refactoring process, and then you could think about, well, how do we get to really good models? Probably we need to do like some tree search or something where we explore different ways of reorganizing the data. Maybe sometimes you're like, oh, this is actually, like we can't go further down. This was like a local max. We need to like think about different ways of reorganizing the data.
Are you imagining that it's like the notion of complexity is like explicitly operationalized in the same way?
Yeah, that's a good. Yeah, I don't know. I think like the simplest possible thing would just be to be like, well, how long is literally how many tokens is the model? But you could. It would also be interesting to somehow to outsource it to the model itself. You could ask the model, like based on your kind of prior on what kinds of models are complex and simple, how simple does this seem? So it could be a more intuitive judgment. But I think ultimately probably it has to be significantly related to program length.
Yeah, it seems for the lab.
Something of entropy metric for the model.
I think the entropy. Yeah. I think that's also reasonable.
It seems like the challenge here is that the model is probably large enough that it's larger than the context. It's large enough that you have to query it, and so that maybe makes it harder to get a sense of like, you can't feed the entire world model into the language model when you ask how complicated is this. You have to chunk it, but then as soon as you're doing that, you're making some kind of decisions about what are natural ways to, like how do you kind of read through the whole model and assess it.
Yeah, that's a good point.
Apart from the tree search, how different is this from doing multiple backward passes and some kind of normalization or dropout?
But it seems like the main difference is the update of operation, which here is like a language model proposing refactors and then those getting accepted or rejected.
So refactors not isn't a backwards pass.
No. This is I guess I didn't say this very explicitly, but the thought is there is a model, either the same model or a different model, which looks at your data and looks at your current world model. Model is super overloaded here, and then suggests like an improvement. And I think eventually something like this is probably gonna overtake gradient descent. I think gradient descent is like a very inefficient way to learn from data. So eventually it will be more like some more kind of reasoning-driven update operation. It might not be exactly like this, obviously, but I think I believe in reasoning-based updates on data eventually.
Yeah, actually, Andreas, I feel like I'm mostly understanding what you're saying, but I'm not quite sure what the context is or something. So like, is this like, oh, like eventually this is probably what the criteria in AI will look like, and we should know about that because that'll like affect us. Because like we should try to build this, or yeah.
I think it's more, I guess. I think I believe like various things with like decreasing levels of certainty. So most confident, like in the beginning of the talk, is like this is like roughly the current picture and where we're lacking, and then here's what here's what explicit world models could look like. I think is more speculative because I don't know that that's actually the way things are going to go. And then, but also I think we should push towards explicitness where possible. And then I think there's a separate question, which is like, what exactly is our role in this picture? I think that's not fully clear, but yeah, I think we should probably be significantly contributing to it in ways that we need to understand. I think I might have like one or two thoughts on this in some slide. Maybe let's talk again at the end if it's not fully addressed. Yeah. So one thing I was also thinking about in the context of these models is how are these models gonna like get superhuman eventually? And one such way is you can, even if you don't observe new data, you can run lots of consistency checks. Like you can take your model and you can be like, okay, like in general, like predictions for different situations, and then the model can ask, well, how compatible are these predictions? Are they consistent? And when you observe that they're inconsistent, you can use that to update your model. So often, like especially if you have a large world model, there will be like some parts that are inconsistent, like you've never thought about how your beliefs about, I don't know, diet relate to your beliefs about, I don't know, the chemistry of sugar or something. There are probably like some beliefs, but they go through like many hops of reasoning. And you could, if you thought more about like, what are the kind of implications of all the things I believe, you could probably improve your model of the world without observing new data. And a claim is that eventually this will be a big component of AI improvement. I think AI will probably eventually have like much more consistent world models than because there will be ways to turn more compute into becoming more consistent. Like you're propagating information between the different parts of your world model through like a kind of self-training, and incrementally kind of improving this like reasoning or this world model that you're building, like somehow like compiling it into this a very robust core where you're like, yep, this is like consistent with everything I've seen. It's like I'm pretty unlikely to update it because it had like so much epistemic pressure. So the original title of the talk was from exascale notebooks to world models. I guess we just jumped to world models, but I think large-scale batch jobs will be super important in this world where you, like, at least I don't know if the explicit world will come true, but I think if it does, then I think large-scale batch jobs will be super important because computing computing inferences from the world model might be expensive, but more importantly, I think this sort of refactoring of the world model, I think, will itself be like a thing you want to run at very large scale, and a specific case of this is you have your like initial maybe stupid world model, and then you want to run over all papers that have ever been published and kind of do this incremental updating until eventually you're like, okay, this is like a great model of a particular domain, or like a great model that can answer a particular distribution of questions for a particular domain. I'm specifically, I guess, I didn't, unfortunately, kind of ran out of thinking capacity here somewhere, but I'm like specifically interested in thinking about like what are kind of the simplest versions of this and how do they scale? Because I think you could probably think of like list of entities or entities and relations often as like simple world models where you're like, this can only answer a very narrow like set of questions, like questions like how are these two cytokines related for any two cytokines or something like that. And so ideally, you would build this like very general architecture where you say, here's the types of questions I want to answer, and now architecture, please assemble a world model that can answer like these classes of questions. And maybe initially it only works for very narrow classes of questions, but then over time it expands, and in the long run, you're like, here's just all the just take the log of all queries people have run in Elicit. This is now our set of questions, and you want to compile a world model that is good at answering all these questions with the data for the world model coming from all the published papers. That's maybe the most expansive vision of Elicit having a world model. Okay. I helpfully made a timeline for implementation. So I think I think the first half of this year we'll probably just like do large-scale async jobs, hopefully sooner rather than later. And I think I'll probably think a little bit more about like this. What are like the simplest possible world models? How does this relate to the entity extraction stuff? Maybe I'll make some prototypes. And I think it would be really nice if, like in the second half of this year, we could already be like, okay, here's like some of the entity stuff we can conceptualize as learning simple world models, and we're running that at scale for like some distribution of questions and some papers.
I don't think I understand why the large-scale async jobs is necessary. Like, I feel like I would start with, in a very, very small context, like 3 claims, 3 pieces of evidence. Okay.
That's the second bullet. So because then in the second half of the year, you want to learn stuff at scale. And so if in the second half of the year, you're like, well, now we need to build the large-scale job infrastructure, then you're already like behind 2 quarters.
I see, okay.
So is this related to like the new science conversation we had yesterday? Would you like that bicycle map?
I think it's actually it was surprisingly related. I think this is exactly maybe I should send this slide to Sasha. I think she's like very much thinking about. I'll be like, James promised we can ship something.
This is all for this year.
Well,
I don't really see how like small world model plus scale equals world model at scale.
Well, so the at scale is still the structure of the world model is very simple. Like it's just like extract the entities or entities and relations.
It has over more observations or something?
Yeah, just over more observations. So it's not like a rich world model that has like, I don't know, bicycle parts and stuff.
Okay.
But I guess the jump from simple to rich world models.
Because it's like this very like large, like discretized world model where like.
It's a very discrete. Yeah, it's not like a dynamic like mechanism moving stuff moving kind of world model.
Okay, so when you're saying world models, I'm trying to picture what someone's looking at on their computer screen.
How are we going to actually build this?
Is this like graph, like node and wire diagram, like crazy visualization? Is that like part of this, or is that like we're unsure what the actual thing we're looking at is?
I think we have no idea what.
I think it.
I've got a similar question, but like, what's the underlying representation? Which might be different, but
Yeah.
like symbolic or statistical?
So yeah, I think currently when I think about it as like text that can include programs and can include math, and the interpreter of that representation can include calls to Python or other symbolic manipulation.
Okay.
So I feel like one way this could go is like we construct a set of user journeys that takes a novice human from like I have no idea what this domain in genomics is to like I read a couple papers, I like come up with some hypotheses, I read a few more papers, and like now I understand genomics or something. And then so like we could construct like think of the product implication as that, like how do we think of the journeys or the flows in Elicit that get a person from like not knowing anything to then being able to model the domain, understand the domain, and then like maybe that's related or it's not related to like there is some program that runs and just like does this, like there's no human component of it, or like
yeah, or like maybe I guess you could think about people at like different degrees of expertness, where maybe a novice can answer very simple questions, like I don't know, you ask them what's a transformer and they'll be like, well, it's like a thing that produces tokens somehow, and then like experts have like higher quality answers, and then you could be like, at what level, what kind of representation is enough to give answers of like a certain quality or concreteness level for a particular domain.
Yeah, I guess there's a question about like whether these two paths are like sequential and helpful for each other, or actually kind of like parallel. So like how helpful is it to try and construct journeys and templates and workflows in Elicit to get a novice human to an expert? Like is that the basis that we train like an independent mechanical agent system on, or do you just like start with the agent system and like completely leapfrog over the person doing stuff? I don't know.
Yeah, I don't know the answer. I think it could be helpful, but not obviously.
So am I right that we wouldn't want to explicitly try to represent the world model to the user? It's something that can be conditioned and then executed and used in lots of different contexts, lots of different interfaces and user experiences could be built on top of it. But the world model itself is more like a kind of kernel that stuff gets built around.
Yeah, I mean, I wouldn't obviously not in a position to commit to anything, but
aside from finishing all of this.
I mean, this is I told you it would get increasingly unhinged. This is the last slide. But I think yeah, I wouldn't kind of want to assume the world model itself you can just take without further like manipulation of any kind and show it to the user, and user will be like, yep, that's the world model. I do think you probably want to have like various ways of, I think, for example, using like counterfactors, interventions, etc. I think you can extract like pretty good representations of many things.
Yeah, it's still a little bit like maybe not to quite the same degree, but we also don't just show users our source code and say, here you go, execute this for your query. So it's at least somewhat in that direction.
Yeah.
Go ahead. Yeah, more of a meta question, kind of related to what Ben was asking. If you think about the frontier of AI and where AI is going, what is Elicit's role in that? And what do we need to be, with respect to that, what do we need to be the best at in the world? Yeah.
Yeah. I think one thing will be kind of being good at kind of flexibly orchestrating large-scale async jobs. I think it's somewhat, unfortunately, I think it is like somewhat unclear what exactly will be needed in the future. So I think you need some flexibility. But as more thinking moves into machines, I think being good at directing this thinking in various ways, like I think this sort of updating and refactoring of world models is like one example of that. I think there are other examples of it. It seems pretty clear that like good orchestration of that thinking is important, but it's less clear what the specific things are gonna be. But I do feel like the exascale stuff is super important, and if we don't get it right, then just we're dead.
I feel like we should be able to like meaningfully influence what is the next equivalent of search and learning. Like, what is this other kind of high-level functional, high-level function that gets more and more powerful with more compute that allows you to make better or like build better models? Like, what is the next kind of version of that?
Yeah, I think one answer is the sort of flexible model updating, where you're like, okay, I have a thing, and I can just run it with more compute and or on more data, and it like builds an increasingly better world model. But I think that's more like a speculative guess than the answer, and I think it's hard to just come up with an answer and commit to it without more experiments.
I feel like for two, like feels like a concrete implementation of this is this sort of like. I feel like I've seen people. Sorry, the second bullet point, prototypes for learning world models, and I think I've seen some people maybe do some stuff with image models, but I don't make full papers exploring the limits. Like reducer type operations, where you say like you can imagine a really simple case of this that I was thinking about when we were talking about summaries yesterday. So you have a summary, you've done this on 8 papers, and you want to say like, given this additional paper, is it like both? Yeah, like does this add anything meaningful to what I've already said here? Does my summarization like need to be changed given this new piece of information? And I think that's like when you think of like what is this like foundation fundamental component, like it's probably not sufficient, but like can you do a reducer and do useful things with this? Seems like a pretty thing you could start working on like without today, that it would tell you meaningful things about whether this like works. Like,
yeah, I think.
Can you actually, given a model that is just like a description of a thing, can you produce meaningful updates to it as you add more information through?
Yeah, I think there's an interesting kind of problem statement here, which is your goal is produce like a really good summary that is at most n words long, and you're gonna observe like a sequence of papers. Maybe it's like I don't know, can be arbitrarily long, and you want to keep updating the summary. I think probably you don't want to take the summary as the representation at each state, because whether you update it or not depends like on latent facts about the papers you've observed so far. But I think that would be, yeah, I would be very excited for someone to work on this problem, although not as excited as shipping features.
For me, sort of on Kevin's point, there's like, I feel like the first part of the presentation amounted to for me like an argument for why like the OpenAIs and Anthropics of the world should like try to build AI systems that are based on like various ways of using reasoning and world models, rather like adding those to current language models or whatever. And then this part is like sort of seems to be saying like, no, we should do that. Yeah, and that feels like a tension to me. Like I feel like we're not we're like not currently that well positioned to like be pushing on like to like make the best model or something like that, or like the best. Yeah, to the extent that like the model and model system are kind of the same thing, like world model and model system are kind of the same thing. We're like not that well positioned to like make the best one. Like so like should we try to become better positioned to do that? Should we like I think my take before this talk would have been like we're not trying to do that. We're trying to like use what OpenAI and Anthropic and whoever come up with to like try to plug that into like doing good reasoning on important questions as much as possible.
Yeah, I guess a few reactions. One is, I think the distinction between you just use what they come up with and like build this model, I think is somewhat fuzzy. Because like at least in this particular conception, like using it is still like, well, you apply the model to do like certain kinds of reasoning about certain types of information environments, and then I definitely agree. People will be and are trying to make their models have better world models in the labs. And I also think it's definitely not a solved problem at this point. So I think even though like maybe in some ways they're better positioned, I think it's not the case that I think new ideas come out of various places. I think it's not clear that who will be doing the most innovation there.
I feel like the best version of Elicit is one with a world model,
Yeah.
with a good world model. So, like, if someone gives it to us tomorrow, we're like, cool, we'll use this. But like, if not, until that is available, like, we have to be pushing forward on how do we give our users like the best model of the domain that they're in.
I think I think it's also the case that the models. I think the default path is more on the implicit world model side, and I think at some point people might be like, that's bad, or might be like, well, we're not going to allow any AI systems with like more than X parameters or something, and then you kind of have to combine explicit and implicit world models, or you have like some high stakes use case where you're like, well, it's really not good enough for us to rely on the implicit world models. We need to like have some more explicit reasoning. Maybe like NIST will be like, hey, we have like some standards for decisions of various kinds of importance, and for more important decisions there needs to be more of a, I don't know, logical like causal chain of reasoning or things like that. So I think the future could look like various combinations of stuff that happens in labs and stuff that doesn't happen in labs, that then together make to constitute like a world model that's more powerful than the thing that is just in the forward paths of the neural net.
But what? Sorry, just related to that. Like, isn't it our role more to help users understand the world model, not necessarily build the world model? Because it's possible that OpenAI might actually build the best world model, but you're still going to need help for the user to understand what that world model is and actually make it explicit.
I think like research is arguably also discovering more about the world model.
Yeah.
So it's a little bit of both. It's like both, like to the extent that we know stuff about the world model that like humans know about our actual physical world.
Yeah.
We should surface that to users really well and help them use it. But like the humans that are our users are also trying to be like, so why do cytokines work in this way? And then they're trying to figure out how to make the collective human world model better.
Yeah, I think like world model is maybe like a little bit too all-encompassing. I think often you probably want like more domain-specific models where, and I think maybe some of the like moat in the future will be about like different organizations having like models that are the best models for a particular domain. You're like, well, I don't want this to live in GPT-7. This is like our unique advantage. So I think I wouldn't think like GPT-7 has like the best model of everything. I think there will be cases where different kinds of systems have better models of particular domains.
I think you can think of like, oh, what is virology? If virology is, you have come up with like a strong model that explains how a certain genre of disease works, and this model is encoded in like what all these, like, you have a description of all these moving pieces, whatever. And I think like you can imagine a maximally narrow version of this, which is like you were using Elicit and you're like trying to say, I want to get like a maximally mechanistic understanding of like a specific disease, like. You care about keratoconus, and you're like, I want to know every like what is our best understanding of all of the like biological factors that cause this. What are the things that like up or down regulate all of those individual processes? If you're a researcher who cares about this problem, that feels like very you are constructing a model of like what is this disease? How does it work? What are like the various levers that are exposed throughout this process? Yeah.
And I think it's possible that some of this will still be through APIs, where you're like, well, I call the update on this observation API that like some foundation model company is making, and then you have some guarantees about your information being private. I think there's still a lot up in the air about exactly where these models are going to live and to what extent they live inside or outside of various companies.
Yeah, I also think like, sorry, was there another question over here?
Yeah, but if you're continuing the thread, to return back to the beta lesson, do you think there's some fundamental reason that, I mean, there's a pretty clear indication that LLMs have representational world models today already? Is the idea that the the kind of, like gradient descent just won't get us to this place fast enough, or that we'll hit some kind of fundamental limit?
It's at least like raising the question. I think it's possible gradient descent is fine for a long time. I think in the very long run, I don't think gradient descent is here to stay forever. I think in the very long run, it's just too inefficient an update mechanism. But
you think it will be some kind of like, it'll still be like heavy in learning, but not gradient descent?
No, I think it will be much more reasoning directed. It will be more like you look like a system looks at a data point. It's like, okay, what are like all the inferences? What changes do I need to make to the model?
I was gonna say, like, to the extent that we really want to take this seriously, or like we really want to get alignment on this, or like clarify it, or like try and make something happen here, I feel like maybe one place where I would want to get more agreement on is when we talk about world models, are we talking about at the level of like a software program or like a workflow in Elicit, or are we talking about it at the level of like a metaphorical vision where Elicit, the ecosystem that is Elicit, the outcome that is Elicit, like has this world model or something? And I feel like that's maybe also related to who does this, because like the more it's like, okay, some algorithmic machine learning breakthrough, maybe it's like a little bit closer to what OpenAI does, and the more it's like humanity has a better way of understanding virology, the more it's like, you know, kind of how Elicit.
I think the way I've been using it, I guess I've been ambiguous, but the way I've mostly been trying to use it in this talk is a world model is basically like an algorithm or a piece of software that can answer like certain types of questions for a certain domain.
But like, does it have to be one piece of software? Or is it like how you use many different types of software to do this? And I guess maybe you start with many pieces and then it gets distilled into one thing more over time.
Yeah, it would definitely have, I guess it's many pieces in the sense that at least the vision that came later was like more of a kind of composite thing than a single neural net.
One of the things that's kind of gestured at in your distinguishing of implicit and explicit components in this thing is that, at least for like the use cases that we're thinking about, the kind of explicit terms of the model need to be like kind of ones that we wanted to use, and then of course, like to some extent, if like the best, most efficient world model like doesn't mention molecules or something in neurochemistry, then like it may be like a great world model, but it's like 7 scientific revolutions in the future or something. It's not helpful to us.
That's interesting.
But it doesn't help us understand things, even if it's like really good at making predictions.
Yeah. So would that just be it answers certain of these questions,
like,
but not?
It can do all those things super well, but it doesn't like give us any understanding of the subject.
And it's not logical to us.
Yeah, it doesn't help our world models.
I wonder if part of this is like your distribution of questions can't be really, like it can't only be object level. You should be asking, like there are higher level questions like, but I want to actually understand this thing, or how do these things fit together, and not just give me the answer to this brute fact.
Yeah.
And I don't need to understand how.
Yeah, I think one of the more interesting things to do here is better understand this distribution of questions for either particular users or particular domains. Like here's like questions of different difficulty level, and here's the ones we would need to be able to answer.
Yeah, because there's like some sense in which it's not just a bunch of natural language questions, right? It's more like a system that you're interacting with that, like it's supporting unless it is like purely just like a chatbot, then it's actually backing some kind of interface that's allowing you to like build up your own mental models and have a workspace.
The more we've been talking about this, I'm getting much more how. Yeah, of course I would think this, but like, when there's this representation, like that's the representation and interaction is like really like OpenAI and Anthropic build models, and then we are the interface to like those powerful things. And like I think this is when you're talking about building a layer in the middle that is like the big complex world model that isn't a thing that users see or interact with directly, but there's a bunch of different interfaces and representations that access that model in different ways.
Yeah.
But representing it well and like allowing them to interact with it well is actually what makes it useful. Like otherwise, it's So updating to me like it can't all be text. Even if you're trying to like represent really complex relationships and comparisons, and it gets into like data visualization and diagrams, and that's usually much more efficient and effective for communicating complex relationships and things. And yeah, it's just about me to be like, graphs and tables and charts, and this is all seems a bit more like important to future listed interfaces in a way we haven't explored yet.
Yeah, I guess that's a good point too. I think when we talk about distribution of questions, I think you could include questions of that form, like the question being, I don't know, what are all the X, Y points on this chart or something.
Yeah.
So it seems like the questions that you're asking of the world model are distinct from it. How does that fit into the picture here? You can imagine when we've done with kind of really rich mega scale world model in 2025, people could still just be asking really crap questions of it, so it's not really stretching it and people getting the most value from it. Is that the way you think about it? Do you think there'd be a sort of separate metacognition kind of a thing? Like, I see you're interested in virology, maybe you should ask about the link between cancer and diabetes or something.
Yeah.
That example of virology. Maybe it's not. But we don't know. Like, there could be a link between virology.
Have you considered that there might be a link between X
a little
and Y?
flippy thing. But yeah, like, would you think that the world model would include that kind of executive function or sort of executive guidance? Or is that something else?
I can imagine that it like makes a prediction for how likely there is to be a connection between these two things or something.
I mean, people might not even know to ask the question. Like, if you see people like Argmites, right, you could say, what's the most likely thing to be related to diabetes? And then it can kind of hum and ha for a while and say...
Yeah, or like imagine there's a workflow that's like, give me something crazy. It's like, here's some
Yeah.
things that are like really unlikely, but yeah.
I would probably try to shoehorn it into the kind of questions you ask the model, like where like one question could be relative to what this person knows, what is the most surprising fact that this model knows?
In addition to having a world model, the second thing is a world model.
Maybe
That's
it's
my basic.
yeah.
We'll collab with Rewind. They give us the world model. We know things the user knows.
You talked to this relevant person 10 months ago.
How crazy would that be though? Like, if assistant could say, here's the thing which is the most surprising.
This is gonna blow your mind.
Click this. You'd never guess what happened next.
Let's pay for research. This is how we get VCs on.
When you're at the
board.
grant next
We're gonna make the most addictive research app.
So I mean I think to me like what I take away from this is more. I think I start from more of the kind of metaphorical vision or like world model as result before world model as input, and so it's like what are the journeys, user journeys, templates, notebooks, workflows we can create in Elicit that allow users to do this, where they see like. Like how likely is this experiment to work given everything else we know in the literature? Or like, okay, here are the results of this study. What else could explain the results of this study? Like those all seem like very imaginable to me. And I think I kind of like thinking about it from the perspective of like, well, science is like all of humanity's effort to build a model of our world. And that world model has probably like the same limitations that you point out. Like it's very inconsistent. Like how can Elicit apply compute to pointing out inconsistencies and like help science and humanity like improve its world model in a more like metaphorical sense.
So it's about understanding the world model, helping users understand the world model,
and maybe like through that point, improving it, being like, oh, it turns out like these two beliefs in science are contradictory. Like we help Elicit realize that these beliefs are or Elicit helps users realize these like certain beliefs are contradictory. And then the researcher could be like, okay, let me run this experiment to like resolve this debate. And then the results of that experiment then help everyone else understand like how does this organ system actually work or whatever.
So there's some ideal world model.
And reality, I think.
Reality.
Yeah.
And
just trying to get there.
Sorry, this is very abstract. But
Yeah.
I'm trying to understand this.
Yeah.
So we're helping
possibly
customers.
not reality though, because it has to have these theoretical virtues. That
Yeah, your reality is like very inconvenient to run interventions on.
Yeah.
Yeah.
What?
Yeah.
But reality is like, I think reality you can only control in certain ways. You can only run for. I can't be like,
Reality has like arbitrary overwhelming detail.
yeah, it has too many constraints.
Okay.
I don't like
I
it.
see, interesting.
So there's two parts of this, right? There's understanding what the best world model is, and then there's helping us explain it to customers, to users. To Maggie's point, like it's not valuable if we don't know a way to actually explain it to people.
Yeah, I mean, to me, it's like we're on the same journey that the user is. Like the user is trying to understand the world model, and we just want to help them. And sometimes we help them by like explaining the parts of the world model that other people know that they don't know. And then sometimes we help them by being like, hey, here's this thing that nobody knows. Maybe you should go figure it out, and that will like improve your world model and everyone else's world model. You know what I mean?
Mm-hmm.
I don't think a world model is something that we're trying to explain to people. It seems like it's an executable tool to help the user to understand something else, which is reality. The world model itself is just a tool to get there. I also, when you were talking at the beginning, like what is a world model, I don't think there is such a thing as like the best world model. There needs to be domain specific.
Yeah, that's why that's why I was like for a particular distribution of questions.
Yeah. So I don't know how much. I mean.
But it could just be like all questions that you ask over the course of your life. So,
Yeah. I think there can be such a thing as like the best scientific world model, but I don't think we need to get into it here. But there's lots of things outside of science which I think are very important. But anyway, that's probably outside of the scope.
Yeah, I'm not sure the value of like trying to explain the world model to the end user is like really that valuable of a thing. If like the thing that we want to do is help users actually like answer these questions.
But often it like the question might be about how a thing works. It's
Yeah.
like maybe you don't want to explain the
does this
entire
happen?
model,
Yeah.
but you want to like project it into like a simpler mechanism and be like, okay, here's how the Wi-Fi radiation affects your brain or something.
Yeah, like I feel like if people ask like, why does caffeine make me jittery? We want to have like we want a list to be able to like have a good answer to that, and for to do that, then it needs a good world model implicitly.
So back to the question of what we need to be the best at. Are we also saying that we are going to limit it to certain domains? To a world models within a certain domain? That's what we're going to be the best at?
I think it's going to be the case that users will come to us with questions about certain domains, and then we want to be the best at like the things they come to us at. Like so for example, like if Sasha comes to us and she's like, I really want to understand the cytokines, then we want to be able to make Elicit kind of become, even if it's like not immediately the best at it, we want her to be able to click some button that charges her $10,000, and then Elicit becomes the best at this particular domain. So it's more like a on-the-fly compiled to specific domains kind of thing.
Text LLM program.
What's that?
We can generate these like text LLM.
Yeah, that's like one way to address it.
Yeah.
But the more important thing is the money in best at the thing out functionality.
So we should be able to cover every domain depending on what users are asking and customize our world model to that domain.
Yeah, at least within, I mean, I guess within science, maybe we can exclude like some other things to
Yeah.
start.
Like, why is Andreas this way?
No,
Unless
but
there's some biochemical
Yeah, I think it's a
type in the
scientific
brain.
question.
Yeah. Some early childhood head trauma, I don't know.
all right, should we wrap up?